RDMIS programming CRD rotate 60 degree. So now we are going to learn how to rotate CRD and also calling the output as per customer requirement. We are going to call out the center distance, angle, maximum center distance, and tap hold center distance and angles. So here you can see on the screen I am going to align the part true to CMM axis. Manually I am going to do this. Let's start with the learn mode on, and remember, so I'm going to change from mm to inch for basic, and this is the mode man. We are going to start the with plane 3 to 1 alignment. 3 points means you are going to base or locate the primary. 2 points for locating axis. You can create a line right at a axis. And third one is a tertiary. A single point will going to define center. So I'm going to make it manually so I can able to align the part and also gives the input to machine that part is locked in the 6 degrees of freedom.
Let's start the programming with the mode man. So first of all, we are going to take plane for locking Z axis. Now I'm going to select circle. For secondary purpose, for secondary locking purpose, I'm going to select a circle which is situated at ZX plane. So here it is. I just change the probe. Okay. So I'm going to get front side hole. So it will going to be my secondary axis locking purpose. Okay, I have a plan. I'm going with a midpoint. Yes, I'm going to get left point and then right point, and from then I'm going to make a construct as a midpoint. And for this midpoint, I'm going to use a secondary axis locking purpose. It's very easy and it is very less time consuming in the future whenever I try to make it. For 3-2-1 alignment, I'm going to do very first thing that my circle for a center point I'm going to project on plane 1. Then my for secondary axis locking purpose, for secondary purpose I'm going to that midpoint projected on plane. Then I will going to make a line or construct a line between a circle and the midpoint projected. So it will going to make a line. So here it is. You can see I have kept z plus for plane 1. I have kept y minus for line which is actually made at y minus, and this is the circle that I have created or projected on the plane. So here it is. This is the basic or sim should I say base alignment for my part. So this is the x y z 3 to 1 alignment. Add an active coordinate system. Now I'm going to move to the mode program mode, as well as keep in your mind whenever you do a program, save as a temporary name, because once your data save, it won't erase, or if something bad happens, it will never erase or keep continue with your set. So here it is. I'm going to make new program. This is the automatic program for further inspection.
Creating a hole with atto. So here it is. I changed the name, and this is the IJK. The XYZ is from right side of below panel. This is the inner dimension. So what is the diameter? And diameter we're going to fill. So after that we will see a preview. So here it is, the small hole, and now I'm going to add an actual. Okay, so right click, generate points 1, and here it is a 360 watt. Okay, there it is, go, and done. So here is the go to. The first one is a, okay, for your clarification, the go to. Okay, so we have a go to added, and the second one is a from near to the first point, measuring points, and this is the last one. So run measure. So when it's clicked, it start to measuring the ID hole. Same process will going to for this hole, but this time we will going to change the name, because it will make sure while calling output it will appear with a different name, and it will be going to be a very clear in the report which dimension we are going to calling out. Well, now I don't have any CAD model, that's why I'm going to take, or I'm going to measure manually these holes, or should I say slot. So here you can see, here we go, that's it. We created our first hole with end initial is a Z plus, and another we will going to use Z minus simply for identifying. And also we are going to use left point and right point for slot 1. Now we are going to simply rotate the coordinate along with z-axis. So here it is. I'm using some space, alignment, rotate 60. Yes, the y-axis will going to, sorry, z-axis will going to rotate. Yes. Okay, add an active. Now the simply process we will going to follow: copy all the data from previous and paste it and replace the name from the editor. Okay, I'm going to use traditional method, just copy and paste and manually changing from the, yes. So here it is. I just get mistaked. I just choose wrong one for putting system. That's why. So I just copy this and paste. But remember, while doing this, you have to replace feature and feature definition. Otherwise, the data will going to overwrite on the previous feature label. So remember, my friends, you have to change feature label, feature defines statement as well as feature actual defined date. For more clarity, I'm going to play the video that how it runs. So here it is, go, and now the video will going to appear on the screen. And I'm going to show you and as well as explain you how it works. So I'm just increasing the speed. This is the probe. Now it will going to select first one, second, okay. See how it moves. We gives the go to, it will avoid collision and as well as taking appropriate point of the slots or feature. So it will replicate the exact output. So remember, while watching this, you have to confirm that shank should not touch the depth point. Okay, that's it. Now left point and right point. Okay, go ahead. Now I will going to show you the appropriate method how to replace. Well, first of all, go to DMIS editor. Before that, you have to bookmark it, and here it is. Change the coordinate name and go to DMIS editor. Select all the data which we have to replace, and here it is, the S2 to slot SL3. just replaced it. But before, selection is important, not a whole file, only selection area. And tap hole 2 to tap hole 3. Done. Okay. Same procedure we're going to follow. Change the coordinate system, change the probing, and do the same. Copy all the data from previous. Change the feature label from replacing SL or slot 3 to slot 4, as well as tab hole 2 to slab hole 3, and run it. So you will going to find out the probe or the machine will going to capture all the parameters or the features that had operated. recalling coordinate 1. Now I'm going to, okay, so I will going to take V plane manually, but for that I'm going to rotate my probe into A 45 degree and B 90 degree, so it will be easy for me. Okay, so where it is, okay, I just messed up. Okay, found it. Yeah, here it is. Here it is. Yes, 45 degree, 90 degree. Okay. Text outfill, text operate. So I will able to share my thought. Take V plane face manually. Here it is a man mode. Now I'm going to measurement plane, and manually I'm going to take 4 points. Okay. So we have a custom header which we have saved in this way. So copy, and I'm going to paste it simply. While calling output, simultaneously we are going to construct feature as per required. But before that, I will make sure the constructions of the features will be going to be a separate. Okay, so here it is the distance that I'm going to call out. Now I want extreme point. So here it is. I'm going to take extreme point from the front view. I can see preview of a extreme point Z minus. Okay, simply I'm going to cut and paste at above, because the construction feature should be separate. Now same, I'm going to change the circle. So here you can see there is a lot important that if you are making a name changes or feature name changes, it will going to help you to identify which circle, which feature you can able to call out for your extreme point. So remember, every time whenever you are trying to make something or while rotating CRD, gives the name. Okay, so it will be a slot 1 or a rib 1 R1 or something else. Okay, so it will make you help you a lot. Now you can see I'm going to change the ballooning number, and here it is the distance that I will going to call from the plane to. Okay, so I'm going to update the first nominal distance, then there is a lower limit, then there is a upper limit, and simply I'm going to put the extreme point 1 and okay, circle to circle extreme point. So here it is the distance I have got. Same procedure will going to follow for another by changing the numbers. So it will help you a lot if you have an idea how to naming the features or changing the feature label. Now here is the customer drawing. As per customer drawing, we need a center distance, a slot center distance from one side in the x direction. So we have to update the alignment and call the distance. So simply you can see from the yes, and here it is activating second, simply replacing again to now you can see the output. So this is the most important thing, that if you want to require a distance from axis in the updating coordinate system or changing coordinate system, you have to recall the CRD as respect to distance. Okay, so here is the main important thing why I'm creating a reference plane, because if I am able to creating a reference plane, so I can able to project all the center points on that plane, and creating a line that came from that projection. So remember, if you want to make sure that your angle should be getting within tolerance, you have to do this. Otherwise, the projecting point or projecting line makes a different angle, which is not okay.